Hi, this is Ron Cipcic. This is the second part of a three-part series on cost behavior. In this particular segment, we're going to take a look at total and marginal product and the relationship between total and marginal product and short-run costs. In our first video, we took a look at long-run cost choices, and we found that the firm, we called it XYZ Company, which produced widgets, decided to produce an output goal of 40 widgets per day. Based on a production function, that firm decided to produce the output goal of 40 with 4 workers and 16 machines. This combination of inputs, 4 workers and 16 machines, is the optimal input combination to achieve that particular goal. Why? Because we were able to see that the firm minimizes its total cost if it uses that number of workers and that number of machines. So in the long run, the firm is going to choose the number of workers and machines that will allow it to achieve the output goal at the lowest possible cost. We said in the first video that this is good stewardship, that when in fact a company produces an output goal at the lowest possible cost, it is being a good steward of resources, and that would ultimately lead, everything else held constant, to higher profits, and higher profits would be the reward for using as few resources as possible to achieve the goal. So we called this the economically efficient solution. Now, when we move into short-run analysis, the number of machines will be held constant. Let me review this with you. In the long run, all variables, all input variables can change. They're variable. So you can change the number of machines and the number of workers given enough time. But in the short run, you're going to be locked into a certain number of machines. So machines in this example are the fixed input in the short run. Let's go ahead and make a note of that. So let me scroll down a little bit here, and let me jot a few notes down here. So in the short run, let's review this. In the short run, some inputs are fixed. If no inputs were fixed in the short run, there'd be no distinction between short run and long run. Okay? So this concept is helpful because it describes a phenomenon. It describes something that actually happens in the business world, that business people over short periods of time can change certain inputs readily, but can't change other inputs. There's just not enough time to change those inputs. Those inputs that can't be changed in the short run are called fixed inputs. Okay? In our example, machines are the fixed input. And, sorry about that, let's get that a little bit cleaned up. And what number of machines will this firm be using? Well, this firm has set the operation up to produce a goal of 40, so this firm will have 16 machines in place, 16 machines, and this is going to be held constant. This will not change throughout the entire short-run analysis. So make a note, this does not change in the short run, which is the analysis we're doing in this video and in the next one. Okay? So throughout this analysis, we hold the number of machines constant. If it sounds like I'm repeating myself, I am, because people forget this all the time. It's amazing as a teacher to see what people think sometimes, and it's quite common for students to forget in the middle of this problem that the number of machines have been held constant. Okay, now we're going to set up a little table here, and we're going to do some further analysis in the short run. In the far left, we're going to put a column up for workers. Okay, in the middle, we're going to have a column called MP that will stand for something called marginal product. I will talk about that. And then in the far right column, we will have a column headed TP, which is for total product. So this is the number of workers, 0, 1, 2, 3, 4, 5, 6. And the middle column is marginal product. Let's just go ahead and write that out. I'll define it below. Marginal product. And the last column is total product. And total product really is equivalent to Q. Okay, it's the cumulative output of the firm. Now let me go ahead and fill some numbers in, and then I'll do some definitions. Let's say that when the firm has 16 machines in place, but it has 0 workers in place, that it cannot produce any output. That makes sense. We said earlier that you need at least 1 worker to get any output. Let's say that if we have 6, remember the number of machines is being held constant, so 16 machines are in place. The question is when you have 16 machines and 0 workers, how much output do you have? 0. If you have 16 machines and 1 worker, how much output do you have? Let's say 8. These numbers are all being given. 16 machines and 2 workers, let's say you have 22. Uh-oh, that's interesting. We'll talk about that. 3 workers, 16 machines, 32. 4 workers and 16 machines, 40. There's a number we should be familiar with. We said that if you have 4 workers and 16 machines, you're able to produce 40. That was the original output goal of the firm. 5 workers and 16 machines can produce, let's say, 45. 6 workers and 16 machines can produce, let's say, 47. We see something happening here. As we add workers, now notice we're adding a worker at a time. 1, 2, 3. Workers are increasing 1 at a time. Output is not increasing at a constant rate. At first, output is increasing at an increasing rate. Notice we go from 0 to 8 to 22. That's increasing at an increasing rate. After 22, though, after the second worker, we keep adding workers, and our output is increasing, but increasing at what? Increasing at a decreasing rate. 22, 32, 40, 45, 47. Actually, if we went 1 more worker, let's do that. We could say this is 47. So actually, when we add the 7th worker, we don't add anything to our output rate. How interesting. Now, we're going to talk about that, why the total product curve is behaving that way. But before I do that, let me define a few terms. If you take the change in total product, this triangle here is delta. If you take the change in total product and divide it by the change in workers. Now remember what workers are. Workers are the variable input. So if you take the change in total product by the change in workers, divide that, you're going to get something called marginal product. What is marginal product? It's the product added when 1 additional worker is added. So it's the productivity gained when we add 1 additional worker. Now I need to say something up front before we fill this column in, because you could get the wrong impression very easily here. Let me change the color of my ink while I'm over here. We're assuming in this analysis that every worker is of equal quality. This is very, very big. This is called a homogeneous labor force. Homogeneous means every worker is of the same quality. They are equally trained, they are equally motivated, they are equally drug-free, they are equally awake. Now we know from real life experience that workers are not of all equal quality. Some have greater training than others, some have greater motivation than others, some are more sober, less stoned than others. The point is, we grossly oversimplify to say that every worker is of equal quality. But we have to do that to solve this problem. If workers are of different quality, then essentially we can't compare the product of one worker with another worker. which means we essentially can't calculate cost, at least very easily. Okay? So every worker is of equal quality. Now let me say one more thing. When I say that 2 workers could make 22 units and 3 workers could make 32 units, I'm not saying that the third worker made those additional 10 units. Here's what I'm saying. 2 workers can make 22 units. We're assuming they're each working equally hard, they're each equally motivated. So when we say that 2 workers are making 22 units, we assume that they're each making 11. Okay? When we say that 3 workers can make 32, we're not saying that the third worker added 10. Bill, the third worker, added 10. We're saying that 3 workers can make 10 more than 2 workers can. Again, they're all working equally hard. So if 3 can make 32, then it must be that each of them on average is making 10 2/3. Okay? If 4 workers can make 40, it's because each of them are averaging 10. Okay? But we notice that 4 workers making 40 only increase the total product by 8 units over what 3 workers can do, making 32. Okay? So the total product number is the product of the group of workers, not of a particular person named Bill or Mary or Sally or whatever. Now, let's go ahead and plug our numbers in. If we go from 0 workers to 1 worker, what does our product increase by? Our product increases by what? By 8. So our marginal product is 8. Notice I'm changing workers by 1, so this is going to be a very easy calculation. The denominator down here in this calculation is always plus 1. So the change in total product is divided by 1, which means we're essentially saying the change in total product is equal to marginal product. You can basically drop the denominator out because the denominator is always 1. Okay? So we add the second worker, and we go from what? We go from producing 8 to producing 22. The second worker adds 14 units. So 2 workers can make 14 units more than 1 worker. Now let's talk about this a minute. This seems a little bit unusual, but it actually has a possible explanation. It could be that 1 worker, we're assuming this, if 1 worker makes 8, this 1 worker is working with 16 machines and is running like crazy. When that worker is between machines, running from, let's say, machine 4 to machine 1, that worker has not got his hands or her hands on that machine. Okay, the worker is actually between machines, so isn't working on a machine. Now, if we could have 2 workers, you wouldn't have to have as much running time. The workers wouldn't have to be running between machines as much. 16 machines still, but 2 workers handling those machines. There'd be less running time. Running time is essentially wasted time because I don't have my hands on the machine. It's necessary. You have to run between the machines to get from one to the other. You live in time and space. But when I'm not on the machine, I'm not making something. So 2 workers could more than double the input of 1 worker. And that's what we're saying here. There's some efficiency gain when we go from 1 worker to 2, which is increasing the marginal product. Now, when you go from 2 workers to 3 workers, your productivity increases from what? 22 to 32, which means the third worker only adds 10 additional units. You go from 3 workers to 4 workers, you go from 32 to 40, you only add 8 units. And now you can see that this marginal product is dropping. I'm going to talk about that. But at first, marginal product was increasing. It hit a maximum of 14, then it began to decrease. On the third worker, notice, on the third worker, marginal productivity began to decrease. Add the 5th worker, you add 5 units of output. Add the 6th worker, you add 2 units of output. You add the 7th worker, you don't add any units of output. But be careful. We're not saying that the 7th worker is a bum. We're not saying that the seventh worker is sleeping. We're not saying that the seventh worker is stoned. We're not saying that the seventh worker is, untrained. What we're saying is 7 workers can't produce anything more than 6 workers, all workers working equally hard. We've hit some sort of maximum here. The maximum output that this firm can get from 16 machines in the short run is 47. The room is simply getting to what? Well, there actually isn't a room. There's only workers and machines, so these machines are outside, it must be. Well, but there's no outside because there's only workers and machines, so there's no ground to put the machines up. These machines are suspended in space. Workers, I don't know. Okay, well, with these 2 inputs, the most you can get in the short run, workers and machines, is 47 units. You can't get beyond that. That becomes the limit. The room gets too what? Let's say there is a room. The room gets too crowded, and the room size is fixed. The number of machines is fixed. The workers are running out of capital. Okay? This has a name. Let me actually define this for you. Falling marginal product has got a name. It's called the law. We're going to put law in front of it because this is proven and it's important. So this is the law of diminishing returns, which is really the law of diminishing marginal product. What's the law of diminishing returns? It's the law of diminishing marginal product. What is marginal product? It's the productivity of an additional resource when the other resource is being held what? When the other resource is being held constant. Now, in our third segment, we're going to take this information and we're going to derive short-run cost numbers. But before we do that, let's just think ahead. In this example, every worker is being paid a wage. The wage is 56. Every worker is being paid the same rate. Why? Because every worker is assumed to be of what? Equal quality. Equal quality. So they all have the same experience, they all have the same training, they all have the same motivation, etc., etc., etc. So equal quality workers get paid equal wages in a fair world. Now think about this. When we add the first worker, we pay the first worker 56 per day. The first worker adds 8. We add the second worker, we pay the second worker 56. The second worker adds 14. We add the third worker, we pay the third worker 56. But the third worker adds 10. Look at this. We add the sixth worker, we pay the sixth worker the same we pay the first worker, 56. But the second worker only adds 2 units of output rate to our production. In fact, if we hired the seventh worker, wow, that'd be wasteful. We pay the seventh worker 56, we get no additional output for the seventh worker. So what we're going to see here from this is very interesting. We're going to see that different units cost the firm different amounts because of this changing marginal productivity. Changing marginal productivity is going to change the cost of a particular unit. You'll learn in the next segment that the cost of a particular unit is the marginal cost of that unit. So moral of the story, in fact, let's write it out. The moral of the story, the conclusion we're going to get from this, based on changing marginal product, is this idea that different units cost the firm different amounts because because different workers produce different levels. Sorry about that. I would get out my erasing tool, but I don't want to show off. Because different workers produce different levels of marginal product. Okay, this is a to be continued episode. We'll see you in segment 3.